So here first problem, show that the tangent at one extremity of the focal chord of a parabola is parallel to the normal at the other extremity. So first problem, right? So we'll say the proof. Let the equation of the parabola be y square is equal to 4ax. That is equation number 1. So x-axis, y-axis, so origin, this is the parabola y square is equal to 4ax. So yes, a comma 0 be the focus, that is we know. Let PQ be the focal chord, that means a chord passes through the focus. So consider the parametric representation of the points P and Q. So parametric representation, first P at1 square 2at1, right, and Q at2 square is equal and 2at2 coordinates, right. Now slope of SP, so we are taking S a comma 0 and P at1 square 2at1. So using 2-point form of this slope, y2 minus y1 divided by x2 minus x1. 2at1 minus 0 by at1 square minus a. So you will get 2at1. A is common in the denominator, a into t1 square minus 1. A and a numerator in denominator, right? Both a get cancelled. So 2t1 by t1 square minus 1. Similarly, we are going to find the slope of SQ. S is a comma 0 and Q is at2 square 2at2. So same formula, y2 minus y1 2at2 minus 0 by x2 minus x1, at2 square minus a. Same, so in the denominator a is common, take it outside, 2at2 by a into t2 square minus 1. Numerator a and denominator a get cancelled, 2t2 by t2 square minus 1. But SP and SQ lies on the same line segment PQ. So both slopes are equal, correct? Slope of SP is equal to slope of SQ. So 2t1 by t1 square minus 1 equal to 2t2 by t2 square minus 1. 2 and 2 get cancelled. So t1 by t1 square equal to t2 by t2 square. Just to do the cross multiplication, so just we are going to do simplification, right? t1 into t2 square minus 1, which is equal to t2 into t1 square minus 1. Multiply with the t1 on the left hand side, t1 t2 square minus t1, which is equal to, on the right hand side of the equality, multiply with t2 into t1 square minus t2. So taking all the terms together to the left hand side, to t1 t2 square minus t1 minus t2 t1 square plus t2. So we are grouping t1 t2 square minus t2 t1 square. In both the terms, t1 t2 is common. Take it outside, t1 t2 into t2 minus t1. Remaining term t2 minus t1. So t2 minus t1 is common in these two terms. So we will get t1 plus t2 plus 1, sorry, t1 t2 plus 1 into t2 minus t1 equal to 0. So here there are two possibilities. Either t1 t2 plus 1 equal to 0 or t2 minus t1 equal to 0. So suppose if you are having t1 t2 minus t1 equal to 0, that means t2 is equal to t1 and t1 t2 is equal to minus 1. Suppose t1 equal to t2, then what will happen? The p coincide with q, so there will be no focal chord. So that case is not possible. So only possibility is t1 t2 is equal to minus 1. That means t1 equal to minus 1 by t2. That is equation number 2. We know the equation of the tangent to the parabola y square is equal to 4ax at the point p at1 square comma 2at1 is this is the formula, yt1 which is equal to x plus at1 square. So writing x term, y term, then constant term in the standard form of a straight line, x minus yt1 plus at1 square equal to 0. So slope of this tangent, right, this equation, let it be m1. So we know minus coefficient of x term divided by coefficient of y term. So in this case, coefficient of x term minus 1 by coefficient of y term minus t1. So 1 by t1. Now that is equation number 3. We know the equation of the normal at the point at2 square comma 2at2 is, this is also formula, xt2 plus y which is equal to at2 cube plus 2at2. So make it as a standard form of a straight line. First x term xt2 plus y minus the constant term, minus at2 cube plus 2at2 equal to 0. Again we are going to find the slope of the normal at q, right? That is, let it be m2. m2 is equal to minus the coefficient of x term t2, coefficient of y term 1, so minus t2, that is 4. But we know from 2, 3 and 4 m1 equal to 1 by t1. So 1 by t1, that means 1 by minus t1 by t2, because t1 is equal to minus 1 by t2. So that is equal to minus t2, right? So slope of the tangent at p, that is one extremity of the one end extremity, means one extremity of one end of the focal chord, which is equal to slope of the normal at q, right? t2 is the slope of the normal, m1 m2, that is, right? m1 is the slope of the tangent, so slope of the normal, that means the tangent at one end of the focal chord of the parabola is parallel to the normal at the other end. Thanks. Next problem. Show that the foot of the perpendicular from the focus to the tangent of the parabola y square is equal to 4ax lies on the tangent at vertex. So let the equation of the parabola be y square is equal to 4ax. As usual, this is standard form of the parabola. We know focus is a comma 0. Consider the tangent at P. Choose any point on the parabola. So consider the tangent at P. Let q x1 y1 be the foot of the perpendicular from focus S to the tangent at P. So draw a perpendicular. It meets the tangent at Q, that is x1 y1, right? We know the tangent with the slope m to the parabola formula, right? Y is equal to mx plus a by m. So this is the foot of the perpendicular, right? SQ is perpendicular to PQ, right? PQ is tangent. So let the equation of the parabola be 1. Since the point q x1 y1 lies on the tangent, it is clearly lies on the tangent, right? PQ is on the tangent at P. So it will satisfy the equation of the tangent. Put x is equal to x1 and y is equal to y1 in 1. We will get y1 is equal to mx1 plus a by m. That is equation number 2. Now slope of SQ. So using 2-point form of the slope. So here first point a comma 0, second point q x1 y1. So using y2 minus y1, same formula, y1 minus 0 by x1 minus a, that is equal to y1 by x1 minus a. That is equation number 3. Now SQ is perpendicular to the tangent, clearly PQ, right? So SQ and PQ are perpendicular. So slope of SQ is into slope of PQ is equal to minus 1. So product of slope which is equal to minus 1, we know, because if two lines are perpendicular to each other, if and only if the product of this their slope is equal to minus 1. So we will get m into m1 equal to minus 1, right? So using 3, m into y1 by x1 minus a is equal to minus 1. Therefore m is equal to minus x1 minus a by y1. So that is equation 4. Using 4 and 2, y1 equal to, so substituting the value of m, minus x1 minus a by y1 into x1 plus a by minus x1 minus a by y1. Multiplying with the minus first term. So a minus x1 by y1 into x1, right? Second term plus a by a minus x1 by y1. So write it in the reciprocal, a y1 by a minus x1, right? So this is the term, right? y1. So y1 equal to, just take the LCM on the right hand side. y1 a minus x1 is the LCM. Do the cross multiplication. Ax1 a minus x1 into a minus x1, a minus x1 square into x1. A y1 into y1, a y1 square divided by y1 into a minus x1. So again do the cross multiplication on the other side of the equality, right? y1 into y1, y1 square into a minus x1, which is equal to a minus x1 square into x1 plus a y1 square. So multiply with y1 square on the left hand side, y1 square into a minus x1 y1 square, which is equal to a minus x1 square into x1 plus a y1 square. left hand side ay1 square, right hand side ay1 square of the equality get cancelled. So remaining minus x1 y1 square, which is equal to a minus x1 square into x1. So x1 y1 square plus a minus x1 square into x1 equal to 0. So x1 is common, take it outside. X1 into y1 square plus a minus x1 square equal to 0. There are two possibilities, either x1 equal to 0 or y1 square plus a minus x1 square equal to 0. Suppose y1 square plus a minus x1 square equal to 0 means y1 square equal to minus a minus x1 square. The square of any term will not be negative, so this is not possible. So only possibility x1 equal to 0. So locus of q x1 y1 is x is equal to 0, right? So the point travels through move through the line x is equal to 0, but x is equal to 0 is the equation of the y-axis, which is the tangent at the vertex of the parabola y square is equal to 4ax, right? Thanks.